Hello. Okay. Should see the desktop. You should hear me. I think I got my speaker on today. Let's see. Does everything seem okay? Do you see the desktop and do you hear me?
Yep.
Yeah. Okay. Thanks. All right. Okay. So we're gonna continue talking about what the reading side was from way back here, nested loops. So today we're going to continue to talk about nested loops. So we did some examples of nested loops on Tuesday, and we'll finish doing more examples today. And there's a new reading assignment for next week. We'll be talking about methods again. So we'll go back and talk about methods one more time. Talk about we'll go back over again all the ideas of methods once more, because it's a real important idea, so it's worth going over them again. So in this book, there's a whole nother chapter on methods, chapter 5 in this book here. Okay, so now let's see. I put some coding bat problems up there the other day. Please, try solving those. If you have questions about them, please ask. Okay, they're the best way that you can practice programming. Okay, doing one of these a day, I think, is a real good way to practice this course. Be able to do one of these things a day. Okay, now, oh, for the examples I want to do today, they're not up on the website yet. I'll put them up after class. I've got some examples. I have them here on my desktop. So we're going to do some examples that I have on my desktop, and then I'll put these folders up. I'll zip these up and put them up on the website after class, and you can download them and look at the examples. And I'll put any ones we work on today. There's more than we can work on today, so it's a bunch of interesting little examples. We'll do a few of them. I'll put them up here, and we'll do some on the Java visualizer so we can watch them. Okay, now remember, real quick review, we're talking about a loop inside of a loop. That's what we mean by nested for loops, a loop inside of a loop. Okay, now this example here was the first one we looked at. The goal of it was to show you what's happening here. The way you think of it is I starts at 1. Then while you're holding I equal 1, you do this whole loop here. So then j goes from 1 to 6 with I equal 1. When this whole loop is done, you go back to here and you make I 2. Then you go back and do this whole loop here. I is 2 and j goes from 1 to 6. What you got to be careful is when you see a line of code like this, you don't think, oh, they're in 2 for loops. So I goes 1, j is 1, then I is 2, j is 2, then I is 3, j is 3. Remember, it doesn't work like that. You think of it as I is 1, then j steps through 1, 2, 3, 4, 5, 6. Then I is 2, and then you do this line over and over again with I equal 2 and j being 1, 2, 3, 4, 5, 6. Okay, so but it's especially when people are starting, they'll accidentally fall into thinking that these loops are kind of happening at the same time. That while I is counting up from 1 to 4, j is counting up from 1 to 6 somehow at the same time, and it doesn't work that way. You pick an I, and then after you picked an I, then you let the j's run through. And if you look at the output of this, you see it real clearly. Just go to the end. And you can see how with I equal 1, j went from 1 to 6. So in this part of the output, this was caused by the inner loop. The inner loop went from j equals 1 to 6, holding I at 1. Then I switched to being 2, and you went through j all over again. Now with I equal 2, j goes from 1 to 6. Okay, and then after that inner loop repeats itself, then you go up to I equals 3, and j repeats itself. Okay, so another way to think about it is, as this thing is looping, I has a value that doesn't change. While this is looping, I has an unchanging value. The value of I doesn't change until this loop is over. You go back up here, then change I, then start the loop. So while you're looping in this inner loop, the outer loop variable is a constant. For in this loop here, I just has one value, but it's a little bit tricky because it doesn't really have one value. After you've looped and go back up, then I changes. But we tend to think of it as while this thing is looping, the I doesn't change. The I's not changing while this thing is looping. It changes between the loops of this guy. Okay. Now, it's real common with nested for loops to be thought of as tables. And if you go to the reading assignment, that's kind of the way they jump right into it. So if you go to this reading assignment, you notice that their nested for loop thinks of it as row and column. Okay. And it's very, now, not all nested for loops are about rows and columns. We just saw this one's not about rows and columns. This was not a table. This is just a bunch of output. It's not really a table. That's not the first row, second row, third row, fourth row. There's no columns. Okay. But it's pretty common for a nested for loop to be about the outer loop picks what row you're in, and then the inner loop picks what column you're in. So this one has 3 rows and 5 columns. Okay. And then this thing prints something in a column. And then when this loop is done, then there's this extra line that says, okay, now go back to the beginning of the next row. So you need this thing to make you go back to the beginning of the next row. Okay, so we had an example like that in our second. That was this one, I think. Let's check it. Let me just delete this part here for now. Okay. Go to the end. See, there's a little table. It's got 4 rows and 6 columns. Okay. Okay. Now, here I'm using the pattern that the textbook pointed out. Oh, sorry. Here I'm using the pattern that their pattern. For row 1 to row 3, I use I instead of row, but from 1 to 4, then from 1 to 6 in the inner one, I did from 1 to 6 in the inner one. Then notice print a character, not print line, print, so that these all go on one line together. So that puts these all on one line together. And then there's the thing that says, let's go to the next line. So for example, if you comment that out, it's not a table anymore. Let's look at what it does. It's not a table now. It's a table only because we did it real carefully. Notice there's no table left. What happened now? When we got into this loop, we printed 6 stars in a row. Then we went up and started another loop of 6 stars in a row, but no one ever said, go to another line. So nothing started another row. So even though this looks kind of like it might be like this, it's not a table because it's missing this one line here. This says start another row. So you gotta be real careful. These things become tables only when you write this very, very carefully like this, okay? Like here's another way where I can goof up and not have a table. So go ahead and put this one back. But suppose you made this ln. Think about it. What is that going to give me as output? I pick an I and I come in here. And what does that for loop do now all by itself? What is this loop doing? What does that loop do? What kind of output does that loop give me right now?
Is it going to give you 6 stars, 6 lines?
Yeah, 6 stars on 6 lines. Instead of 6 stars on a line, it's going to give me 6 stars on in one column. Then this thing will do what? What will
It'll
that?
make a space before making another 6 star, 6 line.
Yeah. So you'll end up with 6 stars in a column with a space. You have 6 stars space, 6 stars space, 6 stars space. No table. So let's look at it. Okay. There's 6 stars, blank line, 6 stars, blank line, 6 stars, blank line, 6 stars, blank line, 4 times. So 4 of those. Now it's not a table, you know, yeah, because I didn't do it just the way this, this is a table because of how carefully it's done. Print here, print line here. So these all do one row because they're prints, they stay on the same row. Then this one says, but now start another row. After you've done one complete row, go and start the beginning of another row. Then you go up here and say, okay, now increment I, and then then do another row. Okay, so notice the row is the for loop and this out together. The for loop prints out the row, and then this thing ends the row and puts you at the beginning of the next row. Okay, and if you don't quite do it exactly that way, you don't end up with a table. So if you put print line here instead of print, or if you forget this one, or suppose I put a print there. Suppose I make them both print. What do I get now? Think, yeah, I want you to start thinking about how code would run. Because this is, when you write your own code, when you do homework assignments, you'll get the output you weren't expecting. You'll write code, and what you wanted isn't what you get. So you have to go back and look at your code and think, what did it really do? So you have to practice thinking what it really does. What will this one do now? Sorry, I couldn't, your speaker wasn't very clear.
It's just gonna make one long line with the space after every 6 stars.
Okay, that's what but the same time, you notice I didn't print anything here. I just said print. I think actually there won't even be a space between the 6 stars because I didn't actually say to print anything at all. When I made it print line, it printed a blank line. Now I'm actually just printing, I think, nothing. Okay, so I think the 6 stars will be they won't be spaced out. There won't be a space between them. So I think it's just gonna be 6 stars, 6 stars, 6 stars, 6 stars all on the same line. Okay, now actually Java complained. Print isn't allowed to be empty. Okay, so you're not actually allowed to, like you can have an empty print line, you actually can't have an empty print. So actually Java wouldn't even let me run this one. Now if I do put something in there like a space, now it'll give me one long line, 6 stars space, 6 stars space, 6 stars space. Okay, 6 star space, 6 star space, 6 star space. And if I go back and make this ln, here's a real subtle question. What's the difference between that output, which looks right, okay, what's the difference between that output and if I delete that space there? Because if I delete that space there, I'll see it seems to be the same output. What changed? Is there any difference between this and that? There is a difference. What is it? Because it's going to matter sometimes. This and this don't do the same thing. Okay, they will look like the exact same output. In fact, here, let me
And then
open
it's just gonna add a space at the end of the line before it adds a new line.
Yes, yeah. So that's not quite the same thing. So let's actually watch it. If I open two windows, I can do one in each window. Okay, so here's one with a space. Look at the output. Here's the one without the space. Look at its output. Okay. Now, are they different? This one doesn't have a space. Watch how I can see that there's something different. If I highlight this and I highlight this, what's the difference?
There's an extra space at the end.
There's an extra space at the end. I only see it if I highlight it, but it's really there, and it does make a difference. Little details like this can drive you batty when you're programming because they do make a difference. When you're writing code in real situations, this might be what's required, no space at the end, and this could cause all kinds of errors because there's actually a space at each. See, at the end of every line, there's actually a space. On this one, there's no space at the end of a line. See, I can't see, if I highlight a line, it starts at the star. Here, if I highlight a line from this end, see how there's something after the star. That's different. That's actually different. I can't just say, oh, that looks to me like that, so they're the same. You're not allowed to say that it looks the same to you. You actually have to ask what's really there. That's not the same thing as this one. Okay, so print line allows an empty line. That just goes from the end of this line to the beginning of the next line immediately. That's usually what you want. Now you can say something like print line like this. That'll print something at the end of the line and then go back to the beginning. What's interesting is you cannot just print nothing. Java doesn't let you print nothing. You can't do that. Java doesn't let you print nothing. It complains if you try to print nothing, but it's okay to print line nothing because then they'll just go to the beginning of the next line. Little details like these, they can make all the difference in the world when you're trying to figure out how to write more advanced code. We'll see situations where these little differences do add up to make, they do amount to different things. Okay, all right. Now, what we've seen is that this is a table if you do it carefully. Nested for loops, where this one does a print, so you're printing all on one line, you're printing character after character on a line. Then at the end of the line, you say, go to the beginning of the next line. Then you go up here and you go to the next row. Okay, so when it really looks like the way they wrote it here, then it's a table, which is a lot of times what you do want. A lot of times nested for loops are used for tables, but not always. Okay, now the nice thing about tables is they give us nice problems to solve. When we think of nested for loops as making tables, there's a lot of cute problems you can do. Okay, so we did, I think it was this one. No, not that one. Okay, let me close some of these. Not that one, the last one. If we print this one out, we're doing a table, but the table's got a shape to it. You know, the table is, it's not, you know, in this case, I'm printing spaces in this part of the table, so it looks like a triangular. It looks like I'm printing out a triangular table. I'm really printing out a square table. It's just that I put spaces in certain places. If I want to see those spaces visibly, I can change this to a dot. For example, if I change this one to a dot, then I see that, yeah, I'm really printing out the whole table. Yeah, I'm really printing out the whole table. Just that some places I print numbers, in some places now I print dots, but I can create nice shapes. And these lead to very interesting puzzles. Yeah, if I give you a shape like this and ask you to write the for loops that create that shape, those are typical programming problems at this point, and they're not easy. They're challenging little programming problems. So I've got a folder here with a whole bunch of these kinds of programming problems. So let me show you examples of a whole bunch of them. We'll work on a couple of them. Okay, So here's a folder called puzzles, and here's a file called puzzles. And if you look at it, here it shows you all the different shapes. So it shows you a bunch of different shapes, and that shape is solved by that file. That shape is done by that one. The third shape is done by that one. Okay, so you can see, you can see the shapes, and then you can see the solution. And then most of these are little like triangle shapes. What they differ is how the numbers grow. Like this triangle has the same shape as this triangle, but in this one the numbers go 1, 2, 3, 4, 5, 6 from left to right. This one the numbers go 6, 5, 4, 3, 2, 1. So notice how this one has 6 in the last column, and you count down to 6. This one has 1 in the last column. I'm sorry, you count up to 6 in this one, and you count down to 1 in this one. So this one has 1 in the last column. This one has 1, 2, 3, 4, 5, 6 on the diagonal. This has 6, 5, 4, 3, 2, 1 on the diagonal. Then down here's another one with the same shape. This one counts up from 1. It's got 1 on the diagonal, and it counts 1 to 6, 1 to 5, 1 to 4, 1 to 3, 1 to 2, 1 to 1. So it counts down on this right edge. So this one, and this one have the same shape, but they put different numbers in that triangle. Okay? And then this one down here is printing out like a letter N. And right now, all of these shapes have a size of 6. They have 6 rows in them. But that should be a parameter. If I write my code nicely, I should be able to write it in a way where I could do this from 1 to 9, or 1 to 5, or 1 to 4. I should be able to change the size of these triangles. Okay, so that's one. So there's a bunch of puzzles. And here's another one. I call them patterns here. Same idea. Similar kinds of problems. Here, the triangles only have stars in them, no numbers. But then here, now notice that here, there's leading spaces before those. You have to have leading spaces before those stars. Here, there actually are no trailing spaces. See, that line ends. You could have trailing spaces, or you could have them there, or you may not have them there. Just like we saw a little while ago. Spaces at the end aren't always obvious, but they could be there. In this case, this triangle does not have spaces at the end, but this triangle has to have spaces at the leading part to push those stars over. And then here, see here I put numbers on the diagonal, dots after, but before the diagonal are spaces. So this has got spaces, number, dots. Then the next row is spaces, number, dots. So each row has got 3 pieces to it now. So we have where each row now has 3 pieces to it. Spaces, number, dot. Okay, and then you can also do other shapes. These are triangles that aren't right triangles. Why not just do a square? Just do the dots on the edge. Make a frame. Here's a frame with a diagonal, and one letter is used on the top and bottom edge, a different letter is used on the left and right edge, and a different letter is used on the diagonal. Okay, so instead of just drawing a frame, you could draw a frame with different letters, and you could put in a diagonal. Here, a checkerboard pattern. Okay, so all of these are tables. All these are rectangular tables with a size. All these have size 6 rows and 6 columns. But it would be nice to be able to do every one of these with being able to say, oh, I want that to have 9 rows and 9 columns, but the same shape. I want this to have 9 rows and 9 columns, but the same shape. I want this to have 4 rows and 4 columns, but the same idea. Okay, so these are typical nested for loop puzzles that are all in this pattern of a table. So they all use more or less, where was that? They're all using more or less this idea here. Okay. But we'll see that for example, in this pattern here, I'm doing the same thing all the way across a row. But we just saw that I may have the row broken up where I do 3 different things across a row. Spaces, number, dots. So we'll see that a lot of times the inner for loop could either be two for loops, one for loop to do the spaces, then one for loop to do the dots. So a for loop to do the spaces part of the row, followed by a for loop to do the dots part of the row, then the print line. Or it could be that inside this for loop is an if statement that asks, am I at the beginning of the row in the first half, so I print a space? Or am I in the last half of the row, so I print dots? So a picture like this can be either done with two for loops inside, two inner for loops, one after the other. First for loop does the first half of the line, second for loop does the second half of the line, or I might do it just like the way it is here, where this for loop goes all the way across the line, but then I put an if statement inside here. And the if statement asks, where am I in the line? Am I at the beginning, the middle, the end? And then the if statement can print out like a space, a number, or a dot, depending on whether I'm at the beginning of the line, the middle of the line, or the second half, the first half of the line, middle of the line, or second half of the line. Okay, so we'll see that you can solve these problems with this kind of a sketch of an outline. We can solve it a couple ways. An if statement inside the inner loop, or possibly two inner loops. One inner loop for the first part of the line, another inner loop for the second part of the line. Okay, so let's look at some examples. Okay, so now, again, every one of these has got a solution in this folder. Okay, so that's example 1. That's example 2. This one's example 3. So this is example 3, just this part here. And then this one here is example 4. Okay, and then this one here would be example 5. Okay, well, let's look at this one. Okay, so let's look at example. That'll be 1, 2, 3. Notice that's a little bit harder than this one, because this one, when you draw, the row, just, you don't go all the way across the row. You stop and like here, the row's length 1, here's length 2, here's length 3, here's length 4, and you don't need to do a second part of the row. So you only need one for loop. Okay, same here. You do the first part of the row, there is no second part of the row. This one starts to be tricky, because now a row really has two parts. You can't somehow not do those spaces. If you don't do the leading spaces, you don't have the stars in the right place. So this one, the inner loop has to either have an if statement to ask, am I at the beginning of the line, or am I at the second half of the line? Or the inner loop has to have the inner loop has to be two for loops, one for the first half, one for the second half. So let's look at example 3. I'll open it in Dr. Java first. So we're going to look for, and actually I think I did, if I remember right, I did it both ways. The two inner loop way and the if statement way. Okay, here's the two inner loop way. And then, oh, no, I didn't do it the if statement way. Not this one. Some of the other ones. Oh, I'm sorry, I opened the wrong one. Oh, I was counting wrong. I'm sorry. This is example 3. Oh, both of these are together in example 3. Yeah, so these two are together in example. I forgot how I wrote it. See, yeah, from one day to the next, it's so easy to forget how you do this stuff. So example 1 is both of those, and example 2 is both of those, and then example 3 is both of those, then example 4 is those. Example 5, I think, is this, and example 6 and 7, I don't, and I think some of the other examples don't have pictures to go along with them. The pictures are in the file. Oh, I'm sorry. 1, 2, 3, 4, 5, 6, 7. Okay, that's 1, 2, 3, 4, 5, 6, 7. Okay, that's the examples 1 through 7. Okay, then what are 11 through 17? Well, we'll open them in Dr. Java and see.
Professor,
Yeah.
is that folder supposed to be on the website?
No, it's not that. Yeah, I'm going to put it up after class.
Oh, okay.
Yeah, I probably should have put it up. Yeah, I'm sorry. I thought I put it up after class, and yeah, that's kind of a mistake because now you can't download them and look at them while I'm talking. Yeah, I probably should have put them. Yeah, I can't. I don't have a way of putting them up there real quickly. I have to log into the web server. Yeah, I'm sorry. Yeah, that's a good point. I should have put them up there before class so you could download them while we were doing them. Yeah, they'll be. I'll put them up there after class though. Okay. Actually, they are up there. Yeah, here. If you want to download them real quick, they're in the other class. They're in yesterday's lecture. So go to the Monday, Wednesday class. Go to lectures and reading. There they are. See, they're up there from yesterday's class. So you can download them if you want by going to the Monday, Wednesday class. Wednesday's class, we'll put them up there. Okay. So you can download them from the Monday, Wednesday class. Okay. Yeah, that's a good point. So yeah, so if you want to open them and look at them right away, go ahead and download them from the Monday, Wednesday class. Okay. Now, what was my naming way? How was I naming my examples? Okay. Okay. So I have 7 examples I have 7 different pictures. Okay. 7 different pictures. There's the 7 different examples. Those are the examples that do it with 2 inner for loops. Then these do them with an if statement. Okay, so let's look. So that's how I named them. I did one set of examples with the inner loop and one using ifs, 2 inner loops. One does 2 inner loops and one does if statements. So let me open them in Dr. Java. So look, here's example 2. Okay, that's this triangle picture and this triangle picture. Okay, and then notice it's using 2 for loops, 2 inner for loops. Now compare that with 12. 12 does the same picture. No, it's still not one of the if statements. Now I've actually forgotten what the difference was. Let me line them up. Here's how you find out what's the difference is. You line them up so you can switch between them. You kind of line them up so you can see where the differences are. Okay, now let's look. Oh, these put the size in a variable, and these put the size hard-coded into the code. Okay, so these didn't have the size. Here the size, see, 6, 6, 6. Okay, so the size is just a number in the code, which is actually not the good way to do it. So then these other ones fix that by putting the size in a variable, and then you could see everywhere where size is being used, which is the better way. Okay. Okay. So that was the difference. Yeah. So the if statement ones aren't even in here. So I should put the if statement ones up here too, because you can do all these with an if statement instead of 2 for loops. So all of them are doing the 2 for loop version, where 1 for loop starts the first for loop does the first half of the line. The second for loop does the second part of the line. And again, yeah, they could all be done with if statements. I think in the other folder I did it that way. Now I'm trying to remember. In the folder on puzzles, see, here's a puzzle with 2 for, see the solution with 2 for loops. Then here's the solution with 1 inner for loop, but an if statement. So in this folder, I did all the puzzles, solving them two ways, using two inner for loops or one inner for loop and an if statement inside of the inner for loop. Okay, I should have done the other folder that way too. I'm going to go back and fix that because that's actually the right way to think about it, is either do it with two inner loops or do it with one inner loop and an if statement. Neither one is a better way to do it. Sometimes the multiple inner for loops reads better. Sometimes the single inner if statement, the if statement inside the for loop, reads better. So it's just a matter of some of them, sometimes one way ends up looking nicer, and sometimes the other way ends up easier to understand. Okay? All right, so let me close these. Okay, let's go back to the example we were looking at. Let's just do this one. I wanted to do this one because this is the one that has leading spaces. Okay, this one's easier because it doesn't have leading spaces and you could ignore the trailing spaces. It's nice to be able to ignore the trailing spaces if you don't have to have them in there, but the leading spaces have to be there. So that's example 2 over here. Okay, all right, so this loop is going to do the leading spaces. You can see it's printing spaces. And then after you've done the proper number of spaces, then you need another loop to continue on that line, printing the stars. So the question is, where does one loop each loop, where does it begin and where does it end? Okay, all right. Now there's a couple ways of thinking about this. I need to go all the way across this row, which has got 6 columns in it. The spaces start, well, notice here there's 0 spaces. In row 1, there's 0 spaces. In row 2, there's 1 space. Well, actually, let's start with this one first. This one will be doing this one up here. In row 1, there's 5 spaces. In row 2, there's 4 spaces. In row 3, there's 3 spaces. In row 4, there's 2 spaces. Row 5 is 1 space, and row 6 is 0 spaces. Okay, so how many spaces should I do? This loop prints the spaces. If I'm in row 1, I do 6 minus 1 spaces. See, I don't do that space. That's not a space. So it's 6 minus I. See, if I'm in row 1, it's 6 minus 1 space. If I'm in row 2, it's 6 minus 2 spaces. So if I'm in row 2, that's 6 minus 2. If I'm in row 3, it's 6 minus 3 spaces. Okay, so how many spaces are there? Start counting at 1 and go up to 6 minus I. Okay, so that does the number of spaces. Then after that, you have how many stars to do. Well, in row 1, 1 star. In row 2, 2 stars. In row 3, 3 stars. In row 4, notice that the number of stars is equal to the row I'm in. So then I can just say for j equals 1 up to I. If I'm in the ith row, I want I stars. Okay, so I have to look at my picture and think carefully of how to count these things, depending on what row I'm in. Row 1, 6 minus 1 stars. Row 2, 6 minus 2 stars. Row 3, 6 minus 3 stars. So row I is 6 minus I stars. And then the second part, row 1, 1 star. Row 2, 2 stars. Row 3, 3 stars. So in row I, there are I stars. 6 minus I spaces and I stars. Okay, so weird way to think. You have to analyze. You have to break the problems up into stages. We're doing a table. Outer loop picks how many rows there are. Inner loop goes across a row. But we're going to go across the row in 2 steps, 2 pieces. So one for loop does the first piece, one for loop does the second piece, Then the system.out line starts another row. Now I start thinking, okay, what goes in here? How many spaces? Now I think row 1, 6 minus 1 spaces. Row 2, 6 minus 2 spaces. Row I is 6 minus I spaces. Okay, that's that loop. Then I switch to the stars. Row 1, 1 star. Row 2, 2 stars. Row 3, 3 stars. Row 4, row I is I stars. Okay. Okay. So there's no, when you do these problems, I can't tell you here's how you do these problems. What we can do is we can do a lot of examples and you start getting a feel of how to think about these problems. There is no rules on here's the recipe for writing a Java program that prints one of these puzzles out. But that's the way real programming works. Real programming is really always about being creative. You know, all programming is about problem solving. You always got little problems you have to solve where if there was a recipe for it, they would get a robot to do it. You know, quite literally, if everything could be solved by some recipe where you just memorize the recipe, that recipe would be programmed into a robot. The whole reason why robots don't write programs is because all programs are solving little problems where there's no recipe. You know, there's ideas, like here, the idea is outer loop picks the row, inner loop goes across a row. Then you look at your picture and see how many pieces does a row have. If a row has 2 pieces, you need 2 inner loops. If a row had 3 pieces, for example, if I made this into something like notice I'm kind of artificially breaking each line into 3 pieces. At signs, question mark, stars. At sign, question mark, stars. Okay. So each line's broken up into, I mean, here I just kind of artificially broke lines up into 3 pieces. Okay. And yeah, it gets a little bit weird because there isn't room for all the 3 pieces here. Okay. But then you would probably need 3, or you would need, since the question marks in between, it would be maybe for loop for the first part, then a line that prints the question mark, then a for loop for the next part. You can see there's the last part changes size, the first part changes size, but the way I did it was the middle part's always a question mark. So it doesn't need a for loop. Okay? So the middle part doesn't need a for loop. The middle part can just be print a question mark. So you look at the picture and then you just see, you think line by line, what do I do in that line? What do I do in that line? How do I do these other lines? Okay, all right. Okay, now let's do another example. Let's look at the pictures, the patterns. Okay, here's one with 3 parts to it. So that's number 3. Okay. If you look at one row, well, notice that if you look at the first row and you look at the second row, the first row doesn't have 3 parts to it. The first row is spaces, then a number. But then you start realizing, wait a minute, but the next row is spaces, number, period. Then the next row, spaces, number, multiple periods. Then spaces, number. So you do think, oh, and then here, notice that there's not 3 parts, there's only 2 parts. So what you think is there's always 3 parts. Here, the third part's empty. Here, the first part's empty. But you have to think that way. You have to think there's always 3 parts, spaces, number, dots. Here, it's 5 spaces, 1 number, 0 dots. Here, it's 4 spaces, 1 number, 1 dot. When you get down to here, it's 0 spaces, 1 number, 5 dots. Okay, So you have to see the 0 there. You have to see the empty. Notice that you have to start seeing emptiness because there really are 3 parts there. 1 part's empty. If I don't program it that way, it'll be harder to program. If I try to program this as a special case, okay, this has got 3 parts, this has got 3 parts, but this has only got 2 parts. And this one's only got 2 parts. Then I've got a bunch of cases of 3 parts and a case of 2 parts. In a case of 2 parts, actually, I got a mess on my hands now. That's harder to think about. What turns out to be easier to think about is they all have 3 parts, size 5, 1, and 0. Size 4, 1, and 1. Size 3, size 1, size 2. And then when I get down here, it's size 0, size 1, size 5. Okay, so I'm going to go down here and I'm going to break. Now, my middle part always has size 1. So here's my 3 parts. First part, middle part, second part. Okay, my middle part's always one thing. It's just the number, whatever. See, if I'm in row 1, it's a 1. If I'm in row 2, it's a 2. If I'm in row 3, it's a 3. If I'm in row 4, it's a 4. So the middle part's just the row number. Okay. Now, the tricky part is this guy. This guy is going to be supposed to be 5, 4, 3, 2, 1, 0. Print. See, it's supposed to print 5 stars, 4 stars, 3 star space. I'm sorry, 5 spaces, 4 spaces, 3 spaces, 2 spaces, 1 space, 0 spaces. So do I have that right here? Okay. In row 1, I print 6 minus 1 space. Remember, there's 6 spaces across. One of them is being occupied by that number. So I print 6 minus 1 spaces. So in row 1, 6 minus 1 spaces. In row 2, I print 6 minus 2 spaces. Well, in row 2, that's 6 minus 2 spaces. In row 3, it's 6 minus 3 spaces. So in row I, it's 6 minus I spaces. Now what happens down here? In row 6, it's 6 minus 6. That's 0, and it prints no spaces. So this loop won't loop, but it'll do exactly what I want. Notice I'll have a loop that does nothing. And that's actually what I want it to do. Because I want it to be 5 spaces, 4 spaces, 3 spaces, 2 spaces, 1 space, 0 spaces. This is starting to think very differently. You're starting to think as empty. You're starting to think of empty as a thing you have to program. I actually had to account for this loop doing the empty case. And that worked out fine. 6 minus 6 is 0. If I increment from 1 to 0, see, when I is 1, 1 is not less than or equal to 0, so it doesn't loop. So I get the empty case down here. Very common trick that I would be iterating down to an empty case. Same thing is going to happen on the right-hand side. Okay, see, this one has to do something very similar. This one is supposed to start with empty. Now let's see. So it starts with 0 dots. Then it has 1 dot. Then it has 2 dots. In row 1, 0 dots. In row 2, 1 dot. In row 3, 2 dots. In row I minus 1 dots. See? In row I minus 1 dots. Now over here, I'm in row 1. Row I minus 1 dot, well, that's 1 minus 1, 0 dots. So it's the right pattern. In row I, and you can see it over here, in row I minus 1 dots. When I'm in row 1, 1 minus 1 is 0, and I print 0 dots. So I programmed in the empty case. Notice I did not do this as a special case of 2 pieces, but this one's 3 pieces, and this one's 3 pieces, 3 pieces, 3 pieces, 2 pieces. I don't want to think that way. The pattern is really more general than that. If I'm allowed to think of empty as my part of my pattern, empty right-hand side, 1 on the right, 2 on the right, 3 on the right. So 0 on the right, 1 on the right, 2 on the right, 3 on the right, 4 on the right, 5 on the right. 5 on the left, 4 on the left, 3 on the left, 2 on the left, 1 on the left, 0 on the left. 0 is the empty case. So with the right way of thinking, I can make this easier than having a special case for this guy and a special case for that guy. So this is a beautiful example. This problem here really shows you a lot of how we think when we write programs. You know, we think in pretty abstract ways. You know, I'm thinking of the empty thing as a real thing, so that I can then go 5, 4, 3, 2, 1, 0. Yeah, that's what my loop does. My loop counts down 5, 4, 3, 2, 1, 0. Yeah. This one starts counting at 0. This one counts 0, 1, 2, 3, 4, 5. Okay. And that's not a normal way to think. I mean, 0 in number was it took humans thousands of years to even invent the number 0. You know, we're not used to thinking of emptiness as something that's there. You know, that emptiness is another case of counting down 5, 4, 3, 2, 1, 0, 0. You know, so that you see this as 3 things: the left part, which has got 5, the middle part, which has got 1, and the right part, which has got 0. See, so it's still 3 things. Very kind of subtle way to be thinking. Okay. All right. Now, this loop did this picture here. Then the next one did this picture here. And there's really, well, let's just look at the difference. Notice how this one, the numbers counted down from right to left. Here the numbers count, I'm sorry, the numbers counted up, but they start on the right and move to the left. Here the numbers count up, they start on the left and move to the right. So now there's 3 pieces on that line. The first piece is empty, then there's the 1, then there's 5 stars. This line's got 3 pieces. There's 1 space in the first piece, then the number 2 is the second piece, and then 4 dots is the third piece. If I keep going down, this is in 3 pieces. 5 spaces make the first piece, 6 makes the second piece, and 0 dots makes the third piece. Okay, so now that's going to be done by this. You can see it's doing spaces before dots. See this one? Yeah, we're still doing, yeah, both of these do spaces before dots. Okay, so they both do spaces before dots. I forget why I had 3 versions here. There's 2 pictures, but I have 3 versions. Let's print them out and see. I think 2 of them, there's 2 versions of one of these pictures and 1 version of the other picture. So actually, this one is the first picture. The third one is the second picture. The question is, well, actually, this one is a repeat. It's either this picture or that picture. So let's actually think as a puzzle. Let's try to figure it out. It's a good puzzle. So what I did is I did one of them 2 ways. I don't remember which one it is. One of these is done 2 ways. So let's look at the middle loop. We can't see. I can't squeeze the whole. Oh, actually, here's what I'm gonna do. Just delete that for now. So now I can see. I want to be able to see the picture and see the code at the same time. Okay. Okay, there's the picture, there's the code. We want to match this code up with one of these 2 pictures. Okay, you'll be doing problems like this on the next, when we get to the next exam. That's actually the kind of problems you'll see on the exam. I'll give you a couple pictures and some code and ask you to match the code to the picture. So let's see if we can match the code to the picture here. It's one of these 2. Okay, so 6 rows. Well, they both have 6 rows, so that wasn't going to help us. Okay, They both start with spaces. Well, this starts with spaces and this starts with spaces. Okay, let's just say row 1. Let's just say what happens in row 1. When I is 1, 1 minus 1 is 0. So this one prints 0 spaces. Well, which one of these starts with 0 spaces?
The second.
The second. So it's doing this one. So the first loop did this one. The second loop does this one. And I think the third loop will do this one again a different way. So, but you can see that, it started out, actually all you have to do is just go one step through it. When I is 1, we go down here, j from 1 to 1, I minus 1, 1 minus 1 is 0. So I'm going to print 0 spaces. Okay, all right. Then I print I, that's the 1. So then I print the 1, and then I print 6 minus 1 stars. That's the 5 dots. I print the 6 minus 1 dots. Okay, so this one did that picture. Okay, now let's check. The next one should do the same picture. Can I squeeze them both in there? Almost. A little bit more squeezing. And get rid of this blank line. I want to be able to compare the two loops. Okay, there. Now I've got them. Here's the picture. So the picture's up here. We can look at the picture, and we can look at the two blocks of code. There's one block of code. There's another block of code. They both should be drawing that picture. Okay, let's check this one. Oh, look at this one. First of all, it does something odd. What's it doing up here? What's that outer loop doing now?
Printing 6 rows.
Pardon me?
It's printing 6 lines.
But how's it doing it? What's different? I mean, this thing printed 6 lines too, but what's different? Something important?
Oh, it's decreasing from 6 to 1.
Yeah, it's counting down. It's letting the I count down. This one, the I counted up. So we thought, well, I is 1, we're in row 1. Well, that's kind of easy. I1 means row 1. But now it's counting down. So now I6 means row 1. Okay, that can get confusing. Okay, I equals 6 is the first row. So now the row counter is counting down. Okay, all right. Okay, for whatever reason, it wanted to choose. So it's counting, it's going 6, 5, 4, 3, 2, 1. Okay, all right. So now that's what this, so we have to remember 6 is the row, I is the row counter, but it's counting down. It's counting, this is row 6, 5, 4, 3, 2, 1. Okay, now look at this loop here. This loop's going to print the spaces. Well, we should start with 0 spaces, then 1 space, then 2 spaces. Okay. Well, if I start with I is 6, what's 6 minus 6?
0.
0. So it prints 0 spaces. So as I counts down, this will give me more and more spaces. So it'll give me 6 minus 6 is 0. Then 6 minus 5 is 1. Then 6 minus 4 is 2. So this will give me 0, 1, 2, 3, 4, 5 spaces. Okay, so that's kind of weird. It's just, doing it a different way. It's letting the I count down, and then it's counting from 1 up to 6 minus I. Okay, but as I counts down, 6 minus I will count up from 0 to 5. All right. So that prints the spaces. Now, after the spaces is a number. Now you have to do a little weird thing. Like in row 1, I is 6. So you want to print 1, so it's 7 minus I. In row 2, I is 5. So you need 7 minus I to get 2. Okay, so you have to write 7 minus I to get that row number there. Okay, now here's the dot part. Does this make sense? We want 5 dots, 4 dots, 3 dots, 2 dots, 1 dot, 0 dot. So when we're in row 6, remember this is row 6 now. In row 6, there's 5 dots. In row 5, there's 4 dots. In row 4, there's 3 dots. So the number of dots is I minus 1 now. See, so the number of dots is I minus 1 because I'm letting I count down. So there's I minus 1 dots. Okay, so this is another version of that picture there. Okay, doing it one way, counting up, doing it another way, counting down. Is one of these right and one of them wrong? No, they're both right. They'll both print the correct thing. This is weird. You'd have to have a good reason for wanting to do it in a weird way like this. There might be a good reason to do this one in a weird way of counting the rows down from 6 to 1. Most people would find this one the better way to do it. Just count the rows from row 1, row 2, row 3, row 4, row 5, row 6. Okay, but somebody might have a good reason for writing it this quirky way. It's correct, a little bit harder to read, but correct. And when you write code, you get to pick the better way you think to do it. But when you have to read somebody else's code, you have to read what they wrote. So you have to get adept at reading people's quirky code just as much as you get used to reading, writing what you think is the good code. You might have chosen to write it this way, which I think is the better way. But at the same time, you may be asked to understand it when it's written this way because that's the way somebody wrote it. Whoever came before you wrote the code this way, and you have to understand it the way they wrote it. So in a work environment, you have to understand the code that's written. Yeah. Sometimes you're allowed to change. If you think it's written poorly and you think it could be written better, you're allowed to change it. But in some environments, you're not allowed to ever change what's already been written. If it works, the old saying, if it ain't broke, don't fix it. So if it works, people don't want to see it changed, even if you think you can write it a better way. So you have to learn to you have to be ready to read what might be a more awkward way to do something. Okay, let's look at another example. Okay. Let's look at this square here. So that would be, see, this was 1, 2, 3, 4, 5. So that's example 5. Example 5 does the square. Okay. Okay. Now, here, remember the other one we did? We said that there's 3 parts to every line, even when it doesn't look obvious that this has 3 parts. There's a part of spaces, a number, and then a part that's an empty part of dots. Okay. This guy, notice that there's 3 parts to this line. Left column, spaces, right column. And you can think of this as also being in 3 parts. Left column, stars, right column. But it's probably not going to be easy to make those somehow all the same thing. Okay. This is an example where I chose to make the top row its own special case. Then I do these rows, which will all look similar. And then I chose to make the bottom row its own special case. Unlike this one, it was not easy to make these all the same case. All of these were 3 parts. What the trick was to understand that the third part might be empty, or the first part might be empty. In this row, the first part was empty. In this row, the third part was empty. And in all the other rows, you could clearly see the 3 pieces. In this example, well, you can say that every row has 3 pieces. The left column, what's in between, and then the right column. But it just didn't work very well because this middle piece looks so much different than this middle piece. Okay, so I thought in this case, I'll just go ahead and do that as one loop. See, there's the loop that'll print the top row. And I thought, okay, then I'll do all these. There's nested for loops that are going to do all of these. Okay, so I'm doing this as a loop all by itself. Then there's the nested for loops that are going to do this part, they're going to do this part of the table. And then there's another loop by itself to do the bottom row. Okay, to me, that was the easiest way to think about this, as opposed to try to do the whole thing as a nested for loop and then somehow treat this row different than those rows. Seemed harder than just say, I'll just go ahead and treat that row as by itself. The nested for loops do this part, and then this part here. That's gonna be my choice. You know, somebody else might say, no, I really want to write this as just two nested for loops. So somehow my inner loop is going to have to determine whether to do this kind of a row or this kind of a row. You might do that with an if statement. You know, maybe an if statement can make that choice. I thought it'd be easier to do it this way. First row, all the other rows, and last row. Okay. Now, what's the first row do? The first row is going to print that many stars. I want there to be a parameter so that I could change the size of this box. And notice I'm not going to just print out one line of stars because I want this number to change. If you go look at number 15, see, number 15, there's a variable that determines how many stars to print out. Okay, so there's a variable that prints out how many stars. So if I want to change the, like if I compile this and run it, right now it's printing out a box with, well, what it is the box, the 6 is the size of this empty space in here. There's 6 spaces and 6 rows in the empty space inside. So the size 6 is the dimension of the empty space. Then if I want the empty space to be much larger, I just change size, recompile, run. Okay, 1, 2, 3, 4. Okay, count how there's going to be 15 rows of empty space. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See, 15 rows. And then there's also, you can check, there's 15 spaces going across here. So the whole box is actually 17 by 17 because the whole box has got a row before, there's a frame around the empty space. So this is the size of the empty space, 15 rows of 15 columns, okay? But I want to be able to just change this number here. So there's a box with a box of size 7 by 7 around an empty space that's 5 by 5. Okay, so the empty space is 5 rows and 5 columns. Okay, so then the code says, well, the top row, see if there's size spaces here, there's size plus 2 stars across. So I do size plus 2 stars. That's the top border. Size plus 2 stars. And the bottom border is going to be the same. Size plus 2 stars on the bottom border. Okay. Then this part does the inner row. This part does the size by size empty space, but with a star on the left and a star on the right. Okay. Okay. So there are size rows. We're doing the size empty rows. That's how many rows there are that have the empty spaces in them. So the outer loop is size. Then here, there's always a star on the left end, and there's always a star on the right end. and then there's size spaces in between. So there's the inner loop that does size spaces in between. Okay, so it's pretty straightforward. Not too much counting. This example doesn't have any crazy counting like this one here did. This one here had much more complicated counting going on. This one's a lot easier. This picture turns out to be one of the easier ones. Okay, the trick here was to think of size as being the inside frame. Okay, so I'm trying to draw this whole box. The whole box is size plus 2 rows and size plus 2 columns. Okay, so go ahead and do the first row by itself, then do the part that's framing the empty space, then do the bottom row. Okay, then the part that's framing the empty space, it's got size rows. Each row begins with 1 star, then it's got size spaces, ends with another star. Now, the person writing the code has to think about breaking the problem into those pieces. Okay, my choice was to break it into these pieces. First row, everything, all the parts that frame the empty space. Last row. Somebody else might say, no, I want to do the whole thing a different way. I'm just going to do 2 nested for loops that do size by 2 by size by 2. And then I'll try to figure out how to handle what's inside here. Okay, and there are ways to write this this is not by any means the only way to write this. Notice that right now I'm using 1, 2, 3, 4 for loops. A for loop here by itself, a for loop here with a for loop inside of it, then a for loop by itself. So I'm using a combination of for loops and nested for loops. Okay, so but it's up to me to think about how do I want to organize the code to accomplish that picture. Okay, now actually let's do this one. Let me show you probably what's even easier way to do this one. So what I'm going to do is I'm going to take that outer, take this for loop and put it after here. What I'm going to do is I'm going to just do the picture a second time. Okay, I'll put a blank line between them. Now, I'm going to do nested for loops that do size plus 2, size plus 2. So I'm just going to say, I'm going to just do 2 nested loops that just iterate from top to bottom, from left to right. Top to bottom, left to right. Okay. Then in here, I want to make a decision. I want to make a decision. If something's true, I'll print a space. Now there's only one other choice. Otherwise, I'll print a star. Now here's what I want you to think. What could I make what can go here? Now our thinking is we're starting in the upper left-hand corner, we're going across that row, then we're going down, going across that row, going down, going across that row, row 1, row 2, row 3, row 4, row 5, row 6, blah, blah, blah. I'm going from row 1 up to row size plus 2. I'm going from column 1 to column size plus 2. And I'm, notice that everything's either a space, everything's either a space or a star. What can go here? What logic says you're a space?
Anything between the top and bottom.
Okay, anything between the top. So well, you got to be between the top and the bottom. Okay, what says I'm between the top and the bottom? The top is row what?
I equals 1.
So the top is row I equal 1. So I don't want to be the top. So I is not equal to 1. So I'm not at the top. And what should I say next?
I does not equal to size plus 2.
Oh, you're breaking up. Your microphone's kind of breaking up. I'm not the top row and I'm not the bottom row. How do I say not the bottom row?
I is not equal to size plus 2.
I is not equal to size plus 2. Okay. Okay. So I'm not the top row and I'm not the bottom row. What else am I supposed to not be to print a space? I should not be in the top row, I should not be in the bottom row, and I should not be what else?
At the beginning and the end of
Yeah, I
the
shouldn't be. No, okay, I shouldn't be in the first column and I shouldn't be in the last column. But who measures columns?
J,
J. So well, J, not what?
not 1.
Not 1, not in the first column. And J, not what?
Size plus 2.
Size plus 2, the last column. Okay. So let's try that. That should be that. Maybe that should be it. Go through the whole table, starting in the upper left-hand corner, go across, and just say, make a decision. If something's true, I print a space. Otherwise, I print a star. Okay. And this one will be blank line. If I get to the end of a line, I print a blank line. So let's compile this. Okay. Run it. See, that was the first way with all the for loops. This was the second way with just 2 nested for loops and an if statement in between. Okay. Try changing a different size. Let's do a size 15. Okay. Seems to work. Now, we've run out of time, so we're going to stop. But, here's a question. Which do you like better? Which was better? This system here that said, do the first row, do what's in between, do the last row. Uses a lot of for loops, but it's kind of straightforward. Or this one. This one ended up being less code. Okay. This one just said, well, start at the top and work your way across the whole thing. And this ask yourself, am I in a place where I should print a star? Or am I at a place otherwise print? I'm sorry. Am I at a place where I print a star, or am I at a place where I print a star? Sorry. Am I at a place where I should print a space, or otherwise I print a star? Okay. Notice how we use compound Boolean expressions. Not row not 1 and row not size plus 2. Row not the first one and row not the last one, and column not the first one and column not the last one. That's a space. Everything else is a star. Okay. The person writing the code gets to decide whether to do it this way or this way. Nobody can tell you the recipe for solving these problems. You just start learning ways of thinking about them. This is a nice way to think. Sometimes this gives you the easiest way to write the code. Sometimes you just need to write a bunch of for loops. Okay, so it could be one way or the other that is the better way to write the code. All right, so we're out of time, so we'll quit here. I'll make these examples up on the website. You can look at them. They're actually little puzzles. They're really meant to be puzzles that you can try to solve. And we'll do some of them in class again. We'll do a couple more of them in class next week, and then we'll start. Well, actually, what we'll do is we'll write methods. The way we'll turn to methods is we can turn each of these patterns into a method that draws that pattern. So that's one way to introduce methods, is say, write a method that draws that pattern. Write a method that draws that pattern where the size, or for example, this could be a parameter to the method. I could change what I print in there at that spot. I could change what number I start with in the upper left-hand corner and what number I count up to. So I can make those parameters to methods. So we'll do more of these puzzles, but we'll make the puzzles into methods. Okay. So if you have questions about these examples, send me an email or arrange a meeting or come to office hours, and also remember, do the next reading assignment. Go and read about, read the review of methods. Read the review of methods in the, read the review of methods in chapter 5 in this book. Okay? All right. So I'll go ahead and stop sharing now and end the message and end the class for now. Have a nice weekend and see you on next Tuesday. Bye.